Welcome to Sri Chaitanya. This is Umasankar, All India IIT Coordinator. Welcome to Vector Algebra classes. My friends, actually, recently we have started the Vector Algebra. Once after completion of the complex numbers, which is the very important topic for JEE Mains and Advanced, we are now concentrating on the Vector Algebra. So far in Vector Algebra, we have completed first 6 lessons. Of that, totally we focused on properties of vectors and problems based on the properties of vectors. After that, the immediate lesson is dot product of the vectors. This is lesson number 7. Today we are concentrating the dot product of the vectors. After complex numbers, why we are handling vector algebra, already I have explained in our previous videos also. There are so many internal and inter-conceptual problems they may ask both for JEE Mains and Advanced examination. In that aspect only, immediately after vector algebra, complex numbers, we are now concentrating the vector algebra. My friends, even in your preparation also, whenever you are preparing vector algebra, together with the complex numbers and if possible, 3-dimensional geometry also, you add an extra lesson in your preparation to strengthening more and more, because you will save the time also. Because all the concepts are interlinked one, and more importantly, multiple connective concepts oriented problems we may expect in the competitive examinations. Again, I am requesting all, please don't forget to check the description. There I am providing all the previous videos and important question papers if possible. Today, through this lesson, in a dot product, I am giving the basic essence of the dot product. What is the definition of the dot product and the properties of the dot product. And mainly, the important concept in the dot product is projection and component of a vector. Projection of a vector along a vector and perpendicular to the vector. Similarly, component of a vector. And moreover, the another important point is angular bisectors. Because in competitive examinations, mainly problems were repeated, especially on these two particular areas. Okay. Before going to that, let me concentrate on the definition. This is about the definition of the dot product. What is the definition of the dot product? If A bar and B bar are any two vectors, then dot product between the vectors is denoted by A bar dot B bar, or scalar product between two vectors A bar and B bar is denoted by A bar dot B bar. Both are same and is defined as A bar dot B bar equal to mod A bar mod B bar cos of angle between A bar comma B bar. If cos of angle between A bar comma B bar is theta, then I can also write it as mod A bar mod B bar cos theta, where theta is always lie between 0 to pi. This is about the definition. And if theta is acute, then A bar dot B bar is always greater than 0. And if theta is obtuse, A bar dot B bar is less than 0. Because if theta is acute, mod A bar is positive, mod B bar is positive, and cos theta is positive. Therefore, this total quantity is positive, provided theta is acute. If theta is obtuse, since mod A bar and mod B bar are positive and cos theta is negative, positive into negative becomes negative. And problems were asked based on this simple fundamental aspect also several times in the competitive examinations. Please don't neglect to study this particular area. Now, my friends, again, the basic properties. If I have replaced B bar with A bar, now it becomes A bar dot A bar, which is nothing but mod A bar whole square, or simply I can write it as A square. So, whenever I am writing A square in vector algebra or B square in vector algebra, that doesn't mean that what? Mod A bar whole square, nothing but what? A bar dot A bar. So, these are all are the things that are hidden behind the screen of A bar dot A bar, nothing but A square. Similarly, A bar dot B bar is equal to B bar dot A bar. That means dot product is always commutative. So whenever a bar dot b bar is equal to b bar dot ab equal to ba, that is in real number system. Whenever ab equal to ba, multiplication is commutative operation. So commutative multiplication operation is commutative, that we can say. Similarly, if a plus b equal to b plus a, then addition is commutative. That like that, even in vector algebra, dot product is commutative. These are the basic properties. Similarly, distributive properties. A bar dot b bar plus c bar, we can write it as a bar dot b bar plus a bar dot c bar. And moreover, this is an important property. Whenever a dot product between two vectors is 0, that means the vectors are perpendicular to each other, provided none of them are non-zero. Because if cos theta equal to 0, therefore theta is equal to 90 degrees. That is the reason. So, if anybody is asking to find angle between two vectors, better is you find their dot product. Luckily, if it is 0, then immediately you can say that the angle between the vectors is 90 degrees. So, suppose in a Cartesian coordinate system, that means in OXYZ plane, and this is x-axis, y-axis, z-axis. Along x-axis, if it is my I cap, and along y-axis, this is my j cap, and along z-axis, it is my k cap, or the respective unit vectors, then I dot I equal to j dot j equal to k dot k equal to 1. Because I dot I means unit vector. I dot I means, as per definition, mod I whole square. Mod I whole square means 1. Because I is unit vector. Similarly, j dot j, k dot k. So, I dot I equal to j dot j equal to k dot k equal to 1. I dot j equal to mod j, and cos angle between I and j. What is the angle between I and j? This is 90 degrees. So, cos 90 is equal to 0. Mod I is 1 and mod j is 1 and cos 90 is 0. Therefore, this product is 0. That's why you have taken any two other vectors and dot product between I with any other vector like j and k, automatically it becomes 0, and vice versa. Similarly with the j and similarly with the k. Okay. Now coming to the most important area, projection of a bar on b bar. See my friends, suppose this is origin bow and this is vector. This is OA bar and OB bar are two vectors, and theta is angle between OA bar and OB bar. Let OA bar equal to A bar and OB bar equal to B bar. Say for example, draw a perpendicular AM, that means from A onto vector OB. Then this length OM, I am very clearly pronouncing this is length. That means it's a modulus. This length OM is called projection of A bar on B bar. So projection means it's a length. So that means actually it is a right angle triangle. OMA is a right angle triangle. Therefore, from this right angle triangle, what would be my cos theta? Cos theta is equal to OM by OA. OM by OA. So my OM is equal to what? OA cos theta. OA cos theta. So OA means A cos theta. Suppose this is what? A number. This the same quantity here I have represented like this. So what is cos theta here? Actually, suppose this is what? In other words, this is B by A. So cos theta is equal to B by A. Okay. So projection of A bar on B bar is equal to A bar dot B bar by mod B bar. What is this? Also I can write it as A bar dot B bar by mod B bar. What is B bar by mod B bar? Unit vector, that is B cap. So projection of A bar on B bar is dot product between A bar and unit vector along B bar. Dot product of A bar and first vector and unit vector along the second vector, A bar dot B cap. Suppose this I can write it as what? A bar mod B cap and cos of angle between A bar comma B cap. This is mod A bar, mod B cap is 1 because unit vector. And what is cos of angle between A? As in the diagram, it is what? Cos theta I can write. That is A cos theta, that I have written like this. So the real number I have converted into the vector form, and conveniently I have represented with what? Projection of A bar on B bar as what? A bar dot B bar by mod B bar. And here, this AM, this AM is called, a vector AM is called component of A bar along B bar. That is what? Sorry, this OM is what? Projection, and OM bar is called what? A component of A bar on B bar. So whenever I know the magnitude, and if I know the unit vector along that direction, then you multiply that magnitude with that unit vector, you will get what? Component vector. So component vector is always a, in the statement itself, it contains a vector. So what is OM bar? Component vector of A bar along B bar. What's that? A bar dot unit vector along B bar, that is B cap, A bar dot B cap. That's the same thing I have written like this, A bar dot B bar by mod B bar, because this is a number, and you multiply this convenient. Okay, I do one thing, because component vector is a vector, whereas the projection is what? A scalar. So projection of A bar on B bar is simply what? A bar dot B cap. A bar dot B cap. This is what projection of A bar on B bar. So if I want the component vector of A bar along B bar, what I am doing is conveniently I am multiplying what? Modulus like this. There is no harm if I have done like this, and conveniently if I have written the same formula like this, like this, there is no problem at all. So this is what? B bar by A bar dot B bar by mod B bar into, this is B bar by mod B bar. This is what? Unit vector. That is A bar dot B bar by mod B bar into, this is B cap. The same thing here I have written like this. So B bar mod B bar into mod B bar is mod B bar whole square. So my friends, actually B bar whole square is nothing but B square. Don't get any confusion, that is not a vector. But A bar dot B bar by B square into B bar is nothing but what? Vector component of A bar along B bar. And this AM bar is called perpendicular to B bar. That is component vector of A bar perpendicular to B bar. Perpendicular to B bar means AM. AM means what? As per what is called a triangular law, then you have to subtract A bar minus A bar dot B bar square into B bar. Because B bar plus, here from the diagram, OM bar plus MA bar is nothing but what? OA bar. I want what? AM bar, or MA bar is nothing but what? OA bar minus OM bar. So this is what? Component vector perpendicular to A bar. And this is what? Component vector of A bar perpendicular to B bar. Clear? And if theta is angle between them, cos theta is equal to A bar dot B bar by mod A bar mod B bar. This is what? Cos angle formula, or angle between two vector formula, where theta is, or phi is lie between 0 and pi. So in entire dot product, this is the most important concept, because even in physics also several times problems were repeated, and we can imagine several more important applications, especially on projection and component vector. Again, tell me, what is a projection? Projection of A bar on B bar is, it's a number. What is that? A bar dot B bar by mod B bar. Actually, it is very clear that from this definition, the geometrical interpretation of dot product is nothing but magnitude of the first vector and projection of the second vector on first. That's all. So what is simply dot product? Dot product is nothing but magnitude of the first vector. That means actually what I'm writing, A bar dot B bar is equal to mod A bar mod B bar cos theta. Theta is angle between A bar and B bar. So mod B bar cos theta is what? Projection of A bar on B bar. Projection of A bar on B bar. Clear? So simply, indirectly, dot product is what? product of the magnitude of the first vector, this is magnitude of the first vector, and mod b bar cos theta is what? Projection of the second vector on the first. What is mod b bar cos theta? That is b cos theta is what? Projection of a bar on b bar. So this is the geometrical interpretation of the dot product. Okay. Now coming to, if a bar equal to a1i plus a2j plus a3k and b bar equal to b1i plus b2j plus b3k, what is a bar dot b bar? You just multiply the corresponding ijk coefficients and add them. Sum and product of the ijk coefficient. That means a1 b1 plus a2 b2 plus a3 b3. Because if I have multiplied with other I with j and j with k, dot product becomes 0. That's why ultimately I will get this as the answer. And mod a bar equal to root of what? a1 square plus a2 square plus a3 square mod b bar. Proof is also very simple, not necessary to resolve all the things here, because it is a well-known fact for you. That's why. And here, this is another important one. Maximum value of a bar dot b bar is mod a bar mod b bar, and the minimum value of a bar dot b bar is mod minus of mod a bar mod b bar. Sometimes in maximum minimum concepts point of view also, we may expect questions on this particular area. Now my friends, this is another important result, and it may useful for solving some other questions. So any vector a bar can be written as a bar dot I into I plus a bar dot j into j. Here I j k means unit vectors. Okay, not ordinary vectors. I cap actually here a bar dot I cap into I cap, a bar dot j cap into j cap, a bar dot k cap into k cap. Concept is very simple. Suppose if a bar is equal to a1i plus a2j plus a3k, what is a bar dot I? A bar dot I is a1. What is a bar dot I into I? That is a1i. a1i. Similarly, what? A bar dot j into j is equal to a2j. A bar dot k into k equal to a3k. If I am adding all these things, so a1 I a bar a bar dot I into I plus a bar dot j into j plus a bar dot k into k equal to a1i plus a2j plus a3k, nothing but what? A bar. So any vector I can express like this. This is another important area. Now the most powerful concept in vector algebra is angular bisectors. So please practice these two formulae. Suppose if a bar is this vector and b bar is this vector, that means if a bar is like this and b bar is like this is a bar and this is b bar, and this is angle between a bar and b bar, and the vector which passes through and which bisects the angle between a bar and b bar is called the angular bisector of a bar and b bar. It's very simple. But original definition of angular bisector is what? The locus of the point which is equidistant. That means this, suppose if p is any point, say suppose if p is any point, suppose this is a line and this is another line. This is angle between two lines. This is angular bisector. What is angular bisector definition? So suppose if p is any point, the perpendicular distances. So this perpendicular distance as well as this perpendicular distance. This is PL and this is PM. PL is equal to PM. Locus of P such that PL is equal to PM. Then the locus of P is nothing but angular bisector of these two lines, we can say. So the same definition here also we can apply. And if I have taken the perpendicular distance and by applying previous projection formula concepts, there I may get internal angular bisectors of a bar and b bar. This, suppose these two are the vectors and this is the angle between the two vectors. This is vector a bar by mod a bar plus b bar by mod b bar, because this is resultant of a bar and b bar, lambda into, because any vector. Okay, this is called the internal angular bisector. This is called the internal angular bisector. For any two non-zero vectors, if some angle is between them, then there should be two angular bisectors will exist. Of that, one is internal angular bisector. This is the internal angular bisector. And this vector is, suppose if I have extended the vectors like this. So okay, suppose this is b bar and this is a bar. Then and this is the angle between the b bar and a bar, and this is called the external angular bisector. This is called the external angular bisector. And external angular bisector between A bar and B bar is denoted by lambda into A cap minus B cap. Lambda into A cap minus B cap. That is, A cap means unit vector along A cap and B cap means unit vector along B cap. Okay, this is what external angular bisector. This is internal angular bisector, and this is what external angular bisector. This what external angular bisector. This is external angular bisector. So okay, so these are the for any two intersecting vectors, for any two non-collinear, non-parallel vectors, two angular bisectors should exist. One is called the internal angular bisector, and another one is called the external angular bisector or exterior angular bisector. And internal angular bisector formula is lambda into A bar by mod A bar plus B bar by mod B bar, and external angular bisector formula is lambda into A bar by mod A bar minus B bar by mod B bar. What are A bar by mod A bar by mod A bar? That is unit vector along A bar, and B bar by mod B bar is unit vector along B bar. A bar by mod A bar plus B bar by mod B bar is resultant of the unit vectors along A bar and B bar. Automatically, actually, from this diagram, it is very clear. If I have taken any point, suppose this is vector A bar, and unit vector along A bar is A cap. This is vector B bar, and unit vector along B bar is B cap. Suppose P is a point on the angular bisector such that this OAPB is a parallelogram. Then a diagonal OP is what? The resultant of A bar and B bar. That is nothing but what? A cap plus B cap. So if for internal angular bisector, this is a lambda into, because what scalar it becomes the angular bisector is the matter only. For what value of lambda, this becomes a parallelogram only is the matter here, because if it is the parallelogram, then only here this both angles are same. So this is the concept behind the screen. Forget about all these things, but you need to practice these two formulae. Okay, now my friends, this is about internal and external angular bisectors and projection of a vector along and perpendicular. Hope you enjoyed this video. If you like this, please share and subscribe my channel, and we will meet with vector products in the coming lessons soon.